All right, number 15, we're going to evaluate this problem using L'Hopital's rule. So we are given the limit of as x goes to 0 from the right, because we cannot input negative, well, we could, but we're going to 0 from the right. And then we're going to have x to the power 13x. All right, so if we plug in 0, basically, this will be 0, 0. So we'll get this indeterminate form, 0 to the 0 power. So we got to get it in a different form. The text recommends setting this equal to L. So we're going to say x to the 13 times x power is equal to L. And then we're going to write this in exponential notation. I'm sorry, logarithm notation. So we're going to do ln, or take the natural log of both sides. Or like this, ln x to the 13x is equal to ln. All right, we can use property of exponents, and then we'll bring this multiple to the front. So we'll have 13x ln of x is equal to ln of L. And then we want to just identify L by itself, so we can raise both sides to the power of E. So base E, base E. Now natural log has a base E, and so these will divide out. And so we get that E to the power 13x times ln of x is equal to L. So our L is just this part up here. So we're going to evaluate this, and we'll be able to find E. So focusing exclusively on this part, if we were to plug in 0 here, we'll get 0 times 0. So we're going to write this in that indeterminate form. I'm going to say ln of x, and then I'm going to write 1 over 13x. So this gives me 0 over 0 form, and then I can take the derivative. If I take the derivative of natural log, that will give me 1 over x. Derivative of 1 over 13x, think about it as 13x negative 1. So I'll get a negative 13 times 1, and then minus 1 will give me squared. So this will be over x squared. If I do some simplifying, keep, change, flip, this will give me 1 over x times negative x squared over 13. 1x will divide out, and that will leave me with a negative x over 13. And then from here, if we plug in 0, this will give us 0. So we are saying that L, because this part is representative of L. L came from here. So this part right here is equal to 0. And so if we do E to the 0 power, we get 1. And so we are saying that this limit is equal to 1.